respected convener of this faculty development program, Dr. P. Jayasree garu, and today's resource person, Jayasree Varadarajan, and my dear colleagues, good afternoon, one and all. I am Sunil, working as assistant professor in the Department of CSE, Sri Vishnu Engineering College for Women, Bhimavaram. On this note, I welcome you all to the second day sessions of 1 week national level online faculty development program on societal applications of machine learning. We, the Department of CSE, welcome you all to this program. So before entering into the session, let me convey my gratitude to Jayasree Varadarajan Madam. Ma'am, welcome you to this faculty development program.
Yeah, thank you, sir. Thank you so much. Yeah.
First of all, I'd like to convey our thanks to you, ma'am, because despite of your busy schedule, you joined with us to share your valuable knowledge and insight. Before entering into the session, let me take the privilege to introduce you, ma'am.
Yeah, it's my pleasure. Yeah, please.
Kiran sir, please change the slide.
Just a minute, Sunil. Just a minute.
Yes, sir. Yeah. So good afternoon, ma'am. It is my great honor to introduce Dr. Jayasree Varadarajan. Dr. Jayasree Varadarajan is a technical R&D analyst at AI Foundry, Manchester Metropolitan University, UK. She is a highly dedicated, enthusiastic, and a professional project analyst with more than 4 years of experience designing, developing, analyzing, and implementing business applications. Currently, she joined as a technical R&D analyst at AI Foundry. She worked as a machine learning research assistant in the Center of Landscape and Climate Research Space Parks, UK, and as a project analyst with a hands-on experience in AI and ML projects in the reputed organization in India. She completed her master's in satellite data science at the University of Leicester, UK. Dr. Jayasree possesses a professional attitude and a solid analytical problem solving, team working, organizational, and time management skills. Really, we are happy to have such a great person as a resource person to this faculty development program. Ma'am, now I request you to enlighten our participants on the topic of machine learning in satellite data science. Now the platform is
Yeah,
yours.
yeah. Thank you, Mr. Sunil, sir, and Jayasree, sir, for giving me this opportunity to give my insights on the satellite data science for the societal application in machine learning application. So it's my pleasure to be the part of this faculty development program. Yeah. So can I share my screen now for the presentation?
Yes, ma'am.
Yeah, thank you. I hope you all can see my slide. Am I?
Yes,
Is it
ma'am.
visible?
It is. It is
Yeah.
visible.
Thank you so much.
It is
Yeah,
in
thank you so
design
much.
mode now.
Sorry?
It is in design mode now. Can you make it in presentation?
Yeah, I will make it as a slideshow. Yeah.
Yes, ma'am. Now it is.
Yeah. Yeah, thank you, sir. Thank you so much. I will proceed with my presentation. Yeah, thank you. So, good afternoon to all the participants. So, I'm here to discuss about the machine learning in the satellite data science. So I'm Jayasree. They have given me the introduction about me. So I'm the technical R&D analyst in the AI Foundry. So next, coming to the agenda of this uh, seminar. So here, the first we will be discussing about what is a satellite data science and the application of the satellite data science, where we will be implementing the machine learning, and we'll be discussing about the geographical information science. So how this geographical information science is related with the satellite data science and the machine learning. So these topics will be covered in geographical information science, and what are the softwares we will be using for this data analysis. That is, this data is a satellite data. So here we are going to see about three case studies with an example with a machine learning application. So the first topic is about the satellite data science. So this satellite data science is to get a detailed information about the natural environment. So the natural environment, in the sense, it can be the atmosphere, it can be the any earth surface, or the land surface, the whatever comes under the natural environment. So the detailed information which we are getting, and it helps to monitor the humans or altering the planet. So it means that if
Yeah.
there is any changes, yeah, is there, hello?
Yes, madam, please proceed.
Yeah, fine. Yeah, thank you. So here it is to monitor whether the humans are altering the planet. So it is a sense the changes in the earth. So the earth changes, the environmental changes. So these changes can be observed by using the satellite images. So this detailed information which we gathered from the environment is known as the satellite data science. So here we are using the data from the space-based sensors to understand and tackle the global environment challenges. So the data analytics techniques which we are used here for processing the satellite observation of the Earth. So here the data is nothing but a satellite data. So this is a satellite image which we obtain from the satellites. So next, for understanding the uh, principles of GIS or the satellite data science, we should have some knowledge on the remote sensing and the programming languages like Python and R for the data analysis. So next, the cutting edge image processing technique, AI, and machine learning techniques have been used in the satellite data science for the uh, getting the detailed information or getting a prediction about the environment and our earth and everything. So this is all about satellite data science. What is satellite data science? So next here we are going to discuss about three applications where we'll be using the machine learning techniques. So the first one is the forest monitoring or the disturbance reduction. So here, using the satellite, we are going to monitor a forest. So usually it's very hard to visit a forest in person and monitor everything as a tree or any other data which we need. So this satellite data will help us to monitor the forest, and it helps us to detect the disturbance in the forest also. So next application is the forest restoration application. So here this is also related with the forest monitoring. So in this, like, it will be a long year project where we will be observing how long, like if you are planting some species 15 years before, and now we need to monitor their growth. So next, we can use the satellite image to monitor the forest restoration every year without visiting the field. So that is a benefit of using the satellite data. So next, this greenhouse gas emission. So in most of the oil and gas industries, mostly in US, will be having a greenhouse gas emission, that is a methane or uh, any harmful gases which will be emitting from the oil and gas industries. So this emissions can also monitored by the satellite data. So from the satellite image, we can just check the value of these gas emissions from the oil and gas industries. So these are the three applications which we are going to discuss in this session. So before entering into the application, we should know what is a GIS. So GIS is nothing but is a geographical information science. So here this GIS is a computer system. So or it is a system which is used for capturing, storing and checking and displaying the data related to positions on Earth surface. So here in this diagram you can see So here, this is the street data. The first one data source will be the street data, which will we are seeing in the outer areas, outer environment. So next is the building data, and next is the vegetation data. So finally, we will be integrating all this data, and we will be viewing in the world map, like in Google or any other maps. We'll be viewing this all integrated data. So this is the geographical information data which will be obtaining from our Earth surface. So it includes what is this data is about. So this data is includes about the people, like about the populations and income, landscapes and vegetation type and sort of. So this GIS is not only focusing on the environment, but also with the figures like populations and income and locations, like any point of interest like restaurants or temples or whatever it may be. So it gives this geographical information science is about, it gives a full data about the environment, earth and everything. So this is the geographical information science. So here it will gives the information about the schools, roads and factories, etc. So all the informations. So here the remote sensing data. So here this remote sensing technology helps us to provide a tool which will be integrated with the GIS, this geographical informations, which is the data collected from the satellite. So these data can be collected using the satellite and which will be used for the further analysis. So here this GIS technologies is using the location. So here, so if we want to access any particular data, like if we want to access only about these college or about only this location of Andhra or only India or any particular location, so the always the location will be the key index variable if you are dealing with the data. So based on this location, we will be having the data. So for each time, so this data will be varies based on the location. So this is all about the geographical information science. So hope you have some clear idea about the satellite data science, GIS and everything, this topics. So here these are some of the softwares which we will be using the for the geospatial analysis. That is nothing but a GIS analysis only. So if we want to analyze any geographical information, the first software will be the ArcGIS. So in this is a client software, so which we can also be used as a server software and online graphic information system. So which is developed by ESRI. So this is European Space Research. So this ArcGIS will be having some of the tools, that is a machine learning algorithms in them. So these softwares will be having the machine learning algorithms where we can implement the machine learning algorithm based on the application. So these tools will be having this machine learning. So we'll be just implementing this algorithm and we'll be checking the accuracy assessments and everything. So these softwares are especially domain specific related to GIS. So ArcGIS and QGIS. So this QGIS is also similar to ArcGIS, so which is a free and open source platform. And this ERDOS Imagine is a software which is designed specifically to extract information from images. Like if you have get any satellite image from any website or about any location, you can get all the metadata about this image by using this ERDAS image software. So from which satellite you have taken and about the vegetative index and water index and everything. So all the data about these images uh, will be extracted by using this ERDAS imagine software. So next, this NV is also similar to ERDAS. So here this software is used to extract the timely, reliable and accurate information about the geospatial imagery. So this will give all the data about the shape files and everything. So this software is also used to give the information about the satellite image. So next, coming to the programming part. So in the previous slide, we discussed about the softwares, especially we used for the satellite image analysis for the geographical information science. So here we will be using the Python programming. So here we are having some set of GIS libraries which we will be using in the Python. So the first one is a raster IO. So here we are using some raster data. So this raster data is nothing but so the points which are in the satellite image. That's there are two types of data will be there. That is a raster data and the vector data. So the locations will be in as a points or a polygons or a lines. So for example, the roads are considered as the line data and the particular location, that is a point, is taken as a raster data. And coming to the vector data, it can be any polygon, which is any shape, that can be a vector data. So for accessing these kind of geospatial data, we will be using this library raster.io. Next is a GeoPandas. So this is similar to the pandas which we are using in the general Python, but this GeoPandas will allow the spatial operations. So with the geometric type, so based on the geometry, it may be a point or a polygon. So based on this geometry, this GeoPandas will be used. Then next is the raster stats. So here this is used to get the statistics, like summarizing the data set of which image we are working or which data we are working. So it will summarize the data. And this Earth Engine API. So this is more important. So most of this GIS will be using the Google Earth Engine API. So this will give the reason. This is a platform which will give the real-time satellite data about the earth. So for example, if you want to access particular location, and if you want to compare this location with the exactly with the other locations, then we can just take this Google Earth Engine as a reference. So, and we can do the analysis. So this Sentinel Sat, so this Sentinel Sat is nothing but Sentinel is a name of a satellite. So this is to access the satellite data directly. So here by using this library, we can search the satellite data, download it, and retrieve the information from the satellites. So this library is used specifically to get the satellite image from the satellites named Sentinel. So this is about some of the important Python libraries we'll be using for the analysis. And next is the R programming. So in the R programming, so here we have some of the libraries, that is a tidyverse library. So here using this library, you can do the data wrangling, tidying, and visualizing. So you can, this is a normal data analysis tool. And next is the map view. So this map view is especially used to create a map for visualizing the data. So here we will be visualizing the data by in the form of an interactive map that is used for the map view. Next is the plot tricks. So this plot trick is nothing but it's plotting of data. Like we can plot the data by using variable charts and variable figures and like that. So this plot trick is used for just for plotting. And ggplot2 is an other important tool. So where we will be marking the locations or any like any specific location or roads or anything by using the ggplot library. And next is the SF library. So here it is to determine the spatial data. Like here we'll be having the this SF library will help us to read and write the data into the R programming. So next is the maps. So this maps, map data, and leaflet. So these three libraries will be used to display the maps. Like we'll be creating some lively maps. So this, like if we can zoom the particular location, or if we want to explore some any particular details from that location, we can use these three libraries where we can view the map as an interactive one. So these three libraries will help us to do these processes. So I think these are the important libraries in R which we'll be using for this analysis. And next, coming to this is the first application which we are going to discuss about. So here this application is on the topic of forest disturbance reduction using a satellite image in the Congo Basin. So here we are taking to this project is focused on the forest disturbance. So the primary objective is to identify. So it is like we can identify the forest disturbances like deforestation, logging, or urbanization in the particular study area. So here we have taken Shangi, which is in the Shopo province in the Democratic Republic of Congo. So here this disturbance is predicted. So here we should have some of the parameters which we have to consider for predicting the disturbances. So here we'll be using the tree cover loss and tree cover gain in the study area. So this is comes under the forest area and some of the residential areas. So here it will be easy for us to do the analysis with tree cover loss and tree cover gain. So we can implement this or predicting this by implementing the maximum likelihood supervised learning algorithm, machine learning algorithm. So for the accuracy assessment, so finally after using this algorithm, we will be using the accuracy assessment. We can use the kappa coefficient calculation, and we have taken the samples. So these samples are taken. So nearly we have classified as 7 classification, and nearly 140 samples are taken. And these samples are compared with the Google Earth engine, which is also taken for the assessment. So as a further development, what we can do is like these disturbances or changes in the forest can be developed as a web application for giving the alerts for the forest service or any forest people where they have to monitor the forest. So this is about this project. So next, if you check with the flow chart, the first step for implementing this project, so I think this will give you a clear idea how we can approach this project and how this machine learning is helps to give the a solution and everything. So here, the first step is to download the satellite images. So that we have to start the analysis by getting the satellite images. So here we have using the Sentinel-2A images to download. So here we have taken the 2 years, that is 2017 and 2022 for the particular study area which we discussed in the previous slide. So next, after downloading it, we have to do some pre-processing of these images. So this image pre-processing, so it includes some geo-rectification process, and there will be a cloud data. So we'll be having some cloud in the particular image which we have download. So we have to do the cloud removal and band composition and projection of the images which we have downloaded. So next, after pre-processing the downloaded these downloading this satellite images, then we have to do the classification. So here is the machine learning part. So here we will be using this classification, land use and land cover. So this classification is nothing but, so here we will be classifying, for example, in the forest, we can just classify by using a dense forest, a normal forest, and the scrap grass, or any other, so like any other plants or a building or any water resources. So we have to classify this land from these images, and for this classification we will be implementing the maximum likelihood supervision classification, and will be creating a signature file. And finally, with this classification, we will be compute the confusion matrix, and final after the finding this matrix, we'll go with the accuracy assessment. So for this accuracy assessment, we will be calculating by using the kappa coefficient, and we will be finding out the user accuracy and the producer accuracy. So this is the overall flow chart for this project, like for analyzing. So here we will be implementing the machine learning part for this application. So here in this analysis, we'll be having here, this is the image of the study area which we have taken. So here we have analyzed for 2017 and 2022. So in the left side, you can see this in this image, this is the 2017 image and 2022. So here this black color is specifically for the deforestation, and red color is for the buildup. So for this, so we have to classify it based on this color, and we can do the dense forest, scrub or grass or water. So water will be mostly in the blue color, and if it's a dark green, then it's going to be the dense forest. So next, if we can compare these two images, we can see more deforestation in the 2022 images. So here you can see some lot of black dots in this image. So this black area is nothing but a deforested area. So this images shows like how we have classified it between the years 2017 and 2022. So this is the basic land use and land cover classification. So next, coming to the accuracy assessment part. So here we have taken the 2022 analysis of the study area. So we have taken 140 samples. So here these points which are marked as in a pink color is the samples which we have taken for considering the accuracy assessment. So this is the first one is the Google Earth engine image, and next is the image which we have worked in the ArcGIS tool. So here I have implemented the supervised learning and have taken this sample, and finally I have computed the confusion matrix, and this is the final result where the overall accuracy will be 92.14 and the kappa coefficient accuracy will be 90.83, and for the user and producer accuracy it is 90.71 and producer accuracy is 92.71. So it shows that it's a good accuracy level for taking this 140 samples. So if we in future we can go for more samples also. So here I have just taken 20 samples for the each classification and did the calculation, compute the matrices and the overall calculate the overall accuracy. So here in this image, this is an image which you can see. This is the changes in the forest area. So this is a satellite image which are taken. Yeah, so here this is the study area. This is the Sangam Mabre district. This is in the Central African forest. So here this is the image. Here I have marked as the study area in the yellow mark. So here this is the study area. So in 2015 and 2016, here in this, if you compare these two images, you can see a small route have been formed in 2016. So it shows there are some illegal roads or some way is created. It shows a tree cover loss. So here the tree cover is lost. So it shows some particular route. So it shows that there is some logging, illegal logging or any human interventions is in the forest area. So it clearly shows by using the satellite images. And this is the 2017. In 2017, you can see lot of sub routes are created. So it shows in 2017, there is a more number of human interventions seen in the disturbances happened in the forest area. So next is when in the next year, in 2018, we can see the most of these routes and 2019. And in 2022, if we check, we can deliberately see the routes, the tree cover loss is so high compared from 2015. So these kind of predictions and these kind of analysis can be done by using the satellite images. So these images will be compared every year and each images are processed and which can be monitored only by using the satellite images. So it's not because it's very difficult for a person or human to entering into this forest and monitor this human disturbances, like human creating these disturbances and everything, or illegal logging or any transport is performing in this forest. So this can be analyzed and this can be changes can be observed and it can be given and as an alert to the forest service by using the satellite images. So this is the application where we have be using these satellite data analysis in the forest disturbances or a forest reduction monitoring and this kind of applications. So here, if you see, this is a movie map which is done from 2015 to 2022. So this pink color mark is nothing but a tree cover loss. So these are the tree covers which lost, and this shows the which is deliberately shows there is particular route is formed for the transport or with the human disturbances from the local people or by the logging people. So this clearly shows the tree cover loss in the particular location, forest location in the Central African uh, part. So next is the carbon biomassing. So here in this project, we'll be calculating the carbon biomass, which is emitted by the hedgerows. So here this study area is a Lancaster. So what they have done is that we have been using the LiDAR data and the point cloud data and the planet data. So here we'll be using the Python and the machine learning model for predicting the carbon biomass, and we will be predicting the future, like how we can reduce this carbon and everything by using this machine learning model. We will be implementing a random forest regression. So here this parameter which we have taken for this machine learning model is the LiDAR data for predictor variable, and we have applied this RF model to predict the biomass. So for this like this application is totally biomass, that it's mapping. So from these plants, the how much biomass is emitted. So for analyzing the performance of this model, we'll be using RMSE and ASCII score. And for this model accuracy, this training data is validated using a five-fold cross validation. And here, this for hyperparameter tuning and the model optimization, the user defined randomized search was implemented using a scikit-learn. So there are a lot of other tools which we have used in this Python, and we will be doing this. So this image shows that here there are 4 planet image of the particular study area with the blue, green and red values. That is the bands of these images. And finally, we have to calculate the parameters. So this parameter is nothing but, so this is like some parameters which is the height or the leaf area index and the roots and everything, the height, percentiles, everything will be comes under these parameters. And we'll be having a trained data and the test data, and we have created the model, and we have a predictor data. So finally, this performance, this predictor data and the trained and test data will be compared, and will be the performance will is compared by using the RMSE and R square mod or score. So this project is also similar to kind of forest monitoring, but this is some kind of interesting factor. Like, for instance, if any particular forest uh, is completely washed out or completely damaged or disturbed by using any natural calamities, for instance by soil erosion, by like any flood or anything, so by any natural calamities, here this forest department or some environmental agency is taking some action to plant some species in the particular location. So here in this image you can see this is the study area location. So this location is damaged or disturbed by using some of the natural calamities. So here in this project, in May 2006, they have planted nearly 20 native tree species in these 3 locations, and they have analyzed the growth of the trees in May 2019. That is, after 13 years, they are analyzing the growth of the plants which they have planted. So here, this study area is in the Anhami. This is the southeast Brazil Atlantic forest. So here they have, for it's not possible like every year or 2 months once or yearly twice or thrice we have to visit this location. Here they have used the satellite data and the lidar data for monitoring this particular location for checking the growth of the trees. So this will help, for like it will help us to estimate the canopy height and the leaf area index and the above ground biomass and everything, the height of the tree and everything. So you, whether these trees or plant species are growing in a right way. So these can be monitored and this forest area can be restored by implementing the satellite image. So by using the satellite image. So this is the part where we'll be using this satellite data. So the coming to the importance, so there are some organization that is a forest landscape restoration, and there are some pledges which are helps to restore the forest. So this restoration strategy is to restore a degraded site based on its past land use and history, and it will be based on the level of degradation also they will be planting the particular species in the particular location. So next, this is the methane emission. So this emission is also can be monitored by using the satellite images. So like, so here in this image, you can see this is the methane emission from the particular oil and gas industries. So this is the one of the gas industries in Permian Basin, which is in the US. So here on predicting this, like the wasted methane, this is the methane coming out of this industries is a is enough to supply 2 million US households. So it shows like how much methane is wasted by. So this can be analyzed not directly by measuring or just gas analysis or anything. So these can be analyzed even easily by the satellite image. So based on the satellite image prediction, the companies can take action to reduce the methane emission from their industries. So here you can see there are three types of images. This red color image shows the more of methane emission. So these are the three popular industries in US. That is a BP production, Shell, and the ConocoPhillips. So here from this images, the industrial people or the environmental agency, so like from any person who are interested to keep the environment safe, can do this analysis and report to the industries. And there are some of the bodies or organization which will be monitoring this harmful gas emission from these industries. So these images will be helping. So this image analysis and everything will can be done by using the implementing the machine learning algorithm for predicting. So like if this condition exists for the particular months, so we can predict like in future how we can reduce it and what are the actions we can take, and we can predict in future how much more gas will be emitting if this situation continues, and how this can be harmful to the nearby people or location. So these can be predicted by using the machine learning, implementing machine learning in these images. So hope everything is fine, like hope everyone understands. So if you have any queries on this, you can ask me in these slides based on this topic.
Yeah, very good presentation, madam. Yeah, really, it's a fantastic presentation.
Thank you, sir.
Now, I request all the participants, if you have any queries, please you can unmute yourself and ask. Ma'am is ready to answer.
Good afternoon, madam.
Yeah, good afternoon, sir. Yeah.
Madam, excellent session, madam. Actually, previously I know about
Yeah.
GIS, but by your presentation, I really learn how we can convert the GIS captured data to machine learning tools.
Yeah, exactly, sir. So here we'll be implementing the machine learning. So these tools like this ArcGIS and QGIS, these tools will be having their algorithm inbuilt. So where we can use this algorithm directly and we can predict it in future.
Yeah.
So
I
yeah,
used ArcGIS, but I will try for the
Yeah.
second one. Thank you, madam.
yeah, thank you, sir. Thanks.
Any participants?
Participants can interact with madam unmuting themselves. Please unmute yourself if you wish to have an interaction, please.
I hope they are very much clear, madam, because
Yeah.
you clearly explained everything. I got the feeling of you are teaching for a student because you came with the agenda of the starting from satellite data science and its applications, how this geographical information science is going to be involved, and what are the software that is R programming, how we are going to work. And you already discussed about three case studies like monitoring methane emission,
Yeah.
forest restoration, and the forest disturbance detection and all. So really, even as of now, we didn't understand how to monitor the forest. That means the forest
Yeah.
disturbance. You clearly explained with
Yeah.
some images. Thereafter, really, I am mesmerized with a change in forest area with the study of Sangam Abor district now. How it is
Yeah.
going to be varying from 2015 to 16, how the
Yeah.
people are moving around the forest, because no one will dare to find out where this human are roaming like that. So year by year, that means you focused from 2015, 16, 17, 18, by the end of 2020, the graph is becoming from green to so many lines like roads.
Yeah.
Really, we are shocked, ma'am. That means these many roamings are happening in
Yeah.
really, it is very. And one more thing is that tree cover loss, ma'am. You
Yeah.
gave it the image. some pink
Yeah.
color as well as green color is going
Yeah.
to be converting into pink. You are also studied from 2015 to 22, how it is going to vary, as well as due to this, how this carbon biomass mapping with machine learning, and you already forest restoration, how it is going to be restored really, and thereafter you focus with methane emission, how based on the 11 months of satellite data, you focus how we are wasting the methane and all. Really, it is a wonderful session, ma'am. Really, all our participants are have a great feast after their post lunch, ma'am. I hope this.
Yeah, thank you so much, sir. So it's my pleasure to be the part of this faculty development program. Hope it's gives some insights on satellite data science also. So if you have any further doubts, or if you are interested in research or anything related to the satellite data science or GIS, I'm happy to discuss with all the participants also. You can connect me through LinkedIn also if you want to discuss me about this in further. Yeah, happy to discuss it.
Yes, ma'am. Thank you for
Thank you.
your open offer, ma'am. Really, we, the Department of CSC, Sri Vishnu Engineering College for Women, Bhimavaram, we thank you, ma'am, for joining with us to share your valuable insights and knowledge to our participants. Really, we are very much glad to have you as a resource person in this faculty development program. Thank you so much for joining with us.
Yeah, thank you, sir. Thank you all, and thank you. I'm thanking the organizing committee for inviting me for this as a resource person, and a special thanks to Dr. Jayasree for contacting me to do this faculty development program. Yeah, thank you. Fine.
Thank you.